Today we'll look at the review for Test 4. Before I do that, though, I do want to mention that if you have the PowerPoint associated with this lecture, you can click this hyperlink to look at the entire formula list for the test. Any formula on that list will be available to you for the test. If there are any formulas that you need that aren't on that list, you will have to memorize them. But let's get started. Number 1, calculate the simple interest earned, round to the nearest cent. P, the principal, is $3,200. R, the interest rate is 5%. The term, or time, is 1 year. The formula for simple interest is I equals PRT. The principal is $3,200. The interest rate as a decimal is 0.05, and the time is 1 year. Multiply those numbers together, and you find that the simple interest earned is $160. Number 2. Calculate the simple interest earned, round to the nearest cent. Same setup as before. The principal is $4,000. This time the interest rate is 3.9%, and the term or the time is 18 days. The formula is still I equal PRT, but remember, time always has to be given in years. So the principal is $4,000. The interest rate as a decimal is 0.039. But we've got to change the days to years. And remember, and if you've forgotten, you need to go back and think about this. The exact method, you divide by 365 because there are actually 365 days in a year. But we talked about the fact that unless it says otherwise, you should always use the ordinary method, which is assuming that there are 30 days in each month, which gives you a 360-day year. So unless it says the exact method, when you're doing simple interest, always use 360. If it says exact method, that's when you would use 365. So in any case, 18 days is 18 360th of a year using the ordinary method. And when you multiply that all out, you'll get $7.80. So 18 days later, that $4,000 would have paid $7.80 in interest. Number 3. Use the formula A is equal to P times the quantity 1 plus RT to calculate the maturity value of the simple interest loan and round your answer to 2 decimal places. Again, you just plug into the formula. $13,000 is the principal. 8.7% is 0.087 as a decimal. And 6 months is 6/12 of a year, which of course is 0.5 or 1/2. If you multiply 0.5 times 0.087, you get 0.0435. If you add 1 to that, you get 1.0435. If you multiply that by 13,000, you get $13,565.50. And capital A is the amount in the account. Number 4, calculate the simple interest, round your answer to 1 decimal place. P is 2,100. Capital I is 91, that's the amount of interest earned, and T is 8 months. We're using the simple interest formula, but this time we're looking for R, and we know the other variables. So the amount of interest is $91, the principal is $2,100, and the time in years is 8/12 of a year. 8/12 is about 0.666667. Take as many decimals as you can, round at the end. If you multiply 2,100 by that 0.666667, you get 1,400, and 1,400 times R is equal to 91. So if you divide both sides by 1,400, you get 0.065, which if you change it to a percent is 6.5%. Simple interest. Number 5, calculate the simple interest due on a 37-day loan of $1,500 if the interest rate is 9%. Again, it's I equals PRT. We're given that the principal is $1,500, the interest rate is 9%, which is 0.09, and it's a 37-day loan. And as we said earlier, unless it says using the exact method, when you have the daily interest, you use a 360-day year. That's the ordinary method, and that's a default method unless you see the word exact. So that's 37 360th of a year. And if you divide 37 by 360, you get 0.102777778. Don't round that off too much. You may need those decimal places. You can round at the end. And if you multiply that all out, you'll get $13.88 to the nearest cent. when you're doing these problems, carry a lot of decimal places and round at the end. Number 6. The simple interest charged on a 9-month loan of $58,000 is $758. Find the simple interest rate and round your answer to one decimal place. Formula is I equals PRT, again because it's simple interest. The amount of interest was given to be $758. The principal is $58,000. We're looking for R, which is the simple interest rate, and the time is 9 months, which is 9/12 of a year. Remember, your time always has to be in years. If you divide 9 by 12, you get 0.75. If you multiply that by 58,000, you get 43,500. And then if you divide both sides by 43,500, you get about 0.01742529. If you change that to a percent, you've got to move the decimal 2 places to the right. That gives you about 1.742529%. And if you round your final answer to one decimal place, that becomes 1.7%. So always carry a lot of extra decimal places until the very end, because not only on this problem do we have to carry more decimal places because you're going to round at the end, you also have to change it to a percent before you round, which involves moving the decimal place 2 places to the right. So the moral of the story is carry plenty of decimal places until the very end. Number 7. Your electric bill is $126. You are charged 8% simple interest for late payments. How much do you owe if you pay the bill 1 month past the due date? Think of a late bill payment as just like a short-term simple interest loan. In other words, if you're late on a bill, the company is basically charging you interest at a simple interest rate. And if you want to know how much you're going to owe, you use the formula A equals P times the quantity 1 plus RT. P is the amount of the bill, that's like the principal, and capital A is the total amount you owe after the late, and A is the total amount you owe after the late fee. If you plug these numbers in, $126 is your bill. The interest rate is 8%, which is 0.08 is a decimal, and you're going to be a month late, so that's 1/12 of a year. If you take 1/12 and write it as a decimal, you get 0.0833333. If you multiply those numbers together, you get 0.00666667, and if you add 1 to that, you get 1.00666667, and if you multiply that by 126 and round it off to the nearest cent, you get $126.84. So that $126 electric bill you owed becomes a bill of $126.84 if you pay it 1 month late. Number 8. Calculate the compound amount. Use the compound amount formula and a calculator. Round your answer to 2 decimal places. So we know the principal is 800. We know the interest rate is 5% compounded quarterly, and we're doing it for 5 years. This is compound interest. So the formula is A equals P times that quantity 1 plus R over N raised to the NT. The principal is 800. The interest rate is 5%, which is 0.05. You're doing it quarterly. That means 4 times a year, so the N is equal to 4. And you're doing it for 5 years, so T is equal to 5. 5 times 4 is 20 in the exponent. And you can type this directly into your calculator if you want to. On some of these simpler ones, I've been just doing it step at a time. But when you get it to this point, you really could just type it in the calculator. You type in the 800, then you've got that implied multiplication, so you hit times, and then you've got the left paren, and then 1 plus, and then you want to take 0.05 and divide it by 4. Then you want to close and get the right paren. That 20 is in the exponent, so you have to hit the X to the Y button and type in the 20, and when you press equal to, you get A is equal to $1,025.63. So you're perfectly welcome to do it in stages like I've done some of the earlier ones, but really you might want to just consider doing it by typing it in all at once you multiply that 5 times 4 and get 20. Number 9, calculate the future value. Round your answer to 2 decimal places. The principal is $4,400. The interest rate's 8% compounded semi-annually, and then we're doing it for 10 years. Again, just compound interest, you're going to use that same formula for compound interest. The P is the principal. That's like the present value. That's what the money's worth now. The A is the future value. It's what it's worth in the future. And that's what we're looking for. So put in 4,400 for P, put in 0.08 for R. We're doing it semi-annual compounding, so that's twice a year, so N is 2, and we're doing it for 10 years, so T is equal to 10. If you multiply 2 times 10 and get 20 in the exponent, again, one option instead of doing it in stages is just to type it directly into your calculator here. Put in the 4,400, you've got an implied multiplication, so hit times, you've got a left paren, and then you've got 1 plus, then you have 0.08 divided by 2, then you've got a right paren, the 20 is in the exponent, so you want to hit the power button, type in 20, and hit equal to, and when you do that, you'll find that the future value is $9,640.94 to the nearest cent. Number 10. Calculate the present value. Round your answer to 2 decimal places. The P is the present value, or principal and present value are the same thing. The A is the future value. So they're telling you the future value is $40,000 6 years from now, and the interest is 8% compounded monthly. So you use the same formula, but it would be easier if the formula were solved for P. So that's the same formula we were using before, except instead of it being A equal to, we went ahead and solved it for P, and you get P equal to. You can actually plug it into the previous formula and then just solve at the end, but I chose to do it this way. So you plug the numbers in. A is 40,000, R is 0.08, and we're doing it monthly, so N is 12, and it's for 6 years, so T is 6. So one thing you can do is just type it in directly, and if you want to do that, you can type in the numerator, 40,000, the fraction bar is the division, so you type divided by, then you drop to the bottom, and you've got a left paren, and then you have 1 plus, then you have 0.08 divided by 12, then you've got a right paren, the 72 is in the exponent, so you hit the power button, the X or the Y button, type in 72, and press equal to, and when you do that, you'll get $24,790.79. Number 11. If you leave $2,300 in an account earning 4% interest compounded daily, how much money will be in the account after 5 years? Round your answer to 2 decimal places. Again, we're still dealing with compound interest, so it's the formula A equals P times that quantity 1 plus R over N raised to the NT. We're given that the principal is $2,300. That's the amount you put in the account. The interest rate's 4%, which is 0.04. We're doing it daily. And again, there are actually 365 days in a year, but unless the problem says use the exact method, we always choose to use 360 as if every month had 30 days, and that's called the ordinary method, and that's the default method. If it doesn't say exact, you use 360. The only way you would change it to 365 is if the problem said using the exact method, and it doesn't, so use 360. I would take the exponent and multiply it out. 360 times 5 is 1,800, and then I would type that directly into my calculator. Again, it's 2,300, implied multiplication, so you hit times, left paren, 1 plus, then you've got 0.04 divided by 360, then you've got the right paren, the 1,800 in the exponent, so you have to hit the X or the Y button, type in the 1,800 and hit equal to, and you'll get $2,809.20. That's how much will be in the account 5 years later. Number 12. How much interest is earned in 7 years on $8,600 deposited in an account paying 9% interest compounded semi-annually, and round your answer to 2 decimal places. Note that compound interest formula gives the amount in the account, not just the interest. So that means if we're looking at just the interest earned, once we use that capital A equal P times the quantity 1 plus R over N to the NT formula, that will give us the amount in the account. So don't forget, they're only asking for the interest earned. So once we get an answer, we have to subtract off the principal, so we'll find just the interest. So don't forget to do that. You get caught up in these calculations and you forget that you're really not finished when you solve for A. So we start off with our formula. The principal is $8,600. The interest rate's 0.09. We're doing it semi-annual interest, so that's divided by 2, and it's for 7 years, so T is equal to 7. If you multiply the 2 times 7 and get 14, you can type it right into your calculator, and I won't read this out again, but it's the same as some of the earlier problems, and when you type it in, you get $15,926.73. That's the total amount in the account. Now, had they asked how much was in the account at the end of 7 years, that would be the answer. But if you go back and read the question, it just said how much interest did you earn. So you've got to go back and take that $15,926.73 and subtract off the amount you put in, and what's left is the interest. So the answer is actually $7,326.73. Don't forget, they asked for just the amount of interest, so once you get A, you still are not done. You have to subtract off the principal. 13. How much money should be invested in an account that earns 9% interest compounded monthly in order to have $13,000 in 6 years? And round your answer to 2 decimal places. Again, it's the same compound interest formula as before, but they're asking us for the value of P. In other words, that's how much money you should invest in the account. That's the present value of the principal. So I went ahead and solved that formula for P. You do not have to. You can plug it into the original formula and then divide later. But I chose to go ahead and solve it for P before I even start. If you do it that way, it's just a matter of plugging the numbers in. A is the future value. So in order to have $13,000 in 6 years, that's in the future. So the future value is $13,000. The interest rate is 0.09, 9%, and you're doing it monthly, so N is 12, and it stays in for 6 years, so T is equal to 6. I would take the 12 times 6 and get 72, and then I would plug it in the calculator. Again, in some of the earlier problems, I've gone over the keystrokes more in depth, but I'll just put it out there. And when you do that, you get $7,591.01. If you want to know how much you should invest to end up with $13,000 in 6 years, you should invest $7,591.01. Number 14. An amount of $1,300 is deposited for 6 years in an account that earns 8% interest. Round your answer to 2 decimal places. Part A, calculate the simple interest earned. Okay, the simple interest is I equals PRT. The interest rate is 8%, 0.08. We're doing it for 6 years. You multiply those together and you find out the amount of interest is $624. Part B, calculate the interest earned if it's compounded daily. Now this is compound interest, so you use the other formula for compound interest. Plugging in the numbers, still a $1,300 principal. Interest rate still 8%, which is 0.08. You're doing it daily. It doesn't say exact method, so you use 360 for the number of days. And the time is for 6 years. If you multiply the 360 times 6 in the exponent, you end up with $2,160. And at that point, I would just type it directly into the calculator. Enter this 1,300. There's an understood implied multiplication, so you press times. Then you've got the left paren, and you've got 1 plus. Then you have 0.08 divided by 360, then you've got the right paren, and then that 2160 is in the exponent, so you have to press the power button, the X to the Y button, then type in 2160 and press equal to, and you get A is equal to $2,100.78. And finally, they want us to find the amount of interest. Remember, A is the amount in the account. If you want to know just the amount of interest, you've got to take the principal away. Well, it started off with $1,300, so $2,100.78 minus $1,300 is $800.78. So there was actually $800.78 worth of interest earned in that account over that 6-year period. And Part C says how much more interest is earned on the account when it's compounded daily. Just subtract those two numbers. In the first case, you earned $624. In the second case, you earned $878. So the difference between those two numbers is $176.78. So if you compound daily rather than just use simple interest, you'll make another $176.78 more than you would have had it been simple interest. 15. A couple plans to save for their child's college education. What principal must be deposited by the parents when their child is born in order to have $41,000 when the child reaches the age of 18? Assume the money earns 9% interest compounded quarterly, and round your answer to 2 decimal places. Again, we're doing compound interest, so you use the regular compound interest formula. I chose to solve it for P because they're asking about how much the parents need to deposit now, or at least when the child is born, so they'll have a certain amount in the future. If you didn't solve for P and you used the formula, it would still work. You just have to solve for P after you plugged everything in. I simply chose to go ahead and solve for P to start with. Having done that, the future value is how much you want to have when the child reaches 18. That's a time in the future. So that's $41,000. The interest rate is 9%, which is 0.09. It's compounded quarterly, so N is 4. And we're doing it for 18 years, from the time the child was born until the child reaches 18. That's 18 years. I would go ahead and multiply the exponents, 18 times 4, get that exponent answer. That's 72, and then type it directly into the calculator. Again, I've done that several times in more detail in earlier problems if you need to go back and look at that. But if you do those, you'll get $8,260.86. So if the couple wants to end up with $41,000 when the child is 18, they need to put $8,260.86 in the account. Number 16, calculate the finance charge for a credit card that has the given average daily balance and interest rate. Round your answer to the nearest cent. The average daily balance will be $115.04, and the monthly interest rate is 1.35%. If you know the average daily balance, the calculation is extremely simple. You take the interest rate, change it to a decimal. In this case, 1.35% would be 0.0135, and then you simply multiply the interest rate times the average daily balance. So that's $115.04 times 0.0135, and that tells you that the finance charge would be $1.55. So if you know the average daily balance, calculating the finance charge is just that simple. Number 17, a credit card account had a $246 balance on March the 5th. A purchase of $117 was made on March the 12th, and a payment of $200 was made on March the 28th. Find the average daily balance if the billing date is April the 5th, and round your answer to the nearest cent. As I mentioned in the previous problem, finding the finance charge is very easy if you know the average daily balance. So whenever you don't know the average daily balance, that's really the hardest part of the problem. So this problem is actually asking you to calculate an average daily balance. So let's do it. The average daily balance is actually the sum of the total amounts owed each day of the billing period divided by the number of days in the billing period. Now, I will say, if you're willing to go back to what you learned about stats mode earlier, you don't actually need this formula, and this is the way I'm going to show it, because I think it's the easiest way to do it, given the fact that we do know how to use the calculator stats mode. If you do, you want to build a 4-column table. One column for the dates, another column for the change in balance, the third column is the actual daily balance after whatever change occurred, and then the last column is the number of days that balance was in effect. So if you build that 4-column table and follow through step by step, you'll find this very manageable. So what you do is you go to the problem and you read, and you find the first date mentioned in the problem where something happened on that credit card account. And if you read through, March the 5th was the opening day of the account, and it had a balance of $246. So you start off the table on March the 5th and give the credit card account a balance of $246. And then you move through and find the next date. If you read through there, the next date mentioned is March the 12th. So you want to write March the 12th down on the next line of the table. What happened on March the 12th? Something was bought with that card that was worth $117. And so the balance went up by $117. It started off being $246. If you make a $117 purchase, now you owe a daily balance of $363. Now notice that last column has the number of days. So at some point we've got to calculate the number of days these balances were in effect. And at this point we can go ahead and get started. We notice that if the balance changed on March the 12th, if you go back up to the previous line, that $246 balance must have been valid up until March the 12th, which means it started March the 5th and it ended March the 11th, which is the day before that $117 purchase happened. So as you're moving down these rows, you can see how many days the previous row had a balance in effect. So now I can see that that $246 balance was valid on March the 5th, March the 6th, March the 7th, March the 8th, March the 9th, March the 10th, March the 11th, and if you count them, that's 7 days. You can also subtract 11 minus 5 and get 6, but remember, when you're counting consecutive numbers, we covered this much earlier, you have to take the largest minus the smallest and add 1. So if you do 11 minus 5, you got to remember you got to add 1. But if you have any confusion about how many days there are, you can actually just write them out and count them manually, because if you miss the number of days, everything else you do is for nothing because you're going to miss it. So get those number of days right, even if you have to just write them out one by one and count them. But in any case, that $246 balance was valid for 7 days. Now you go back up and read the problem and see what happened next. Well, the next thing that happened is there was a payment made on March the 28th of $200. So now you go to the third line of the table and write down March the 28th and notice that there was a payment made. Now, if you make a payment to the credit card company, your balance goes down. So that's a negative $200, and that balance of $363 goes down by $200 and becomes $163. Also notice that you can now go to the second line of the table and see when the previous daily balance of $363 was valid too. And you can see that the new balance was on March 28th, so the old balance of $363 ended on the 27th. So now we can calculate how many days that $363 balance was valid by subtracting or by counting. If you take 27 minus 12 and add 1, you get 16. But if you have any confusion or any doubt about it, just write the days out and count them. And it turns out there are 16 of them. You cannot afford to miss the number of days, so if it takes writing them out and counting them, do it. And now keep going. The last date mentioned is April the 5th, and that says the billing date is April the 5th. Now you have to be careful. The billing date is actually the first day of the new bill. So don't write down April the 5th, write down April the 4th. The billing date is the first day of the new bill, so the ending date of the old bill is April the 4th. Don't forget, billing date is the first day of the new bill, so you subtract 1 to find the ending date of the bill we're looking at. So that means that the $163 daily balance was valid from March the 28th to April the 4th. Now here's another issue. If you do this problem, you're going to have to know how many days are in March. And a different problem might use a different month. If you cross the boundary of a month, you've got to know how many days that month has. So remember, March has 31 days. You have to know that. And if you write them out, you can see that's March the 28th, 29th, 30th, 31st, and then April the 1st, 2nd, 3rd, 4th. So you have to know which months have 30 days and which have 31, and that February has 28, of course, unless there's a leap year. That turns out to be 8 days then, and now you're set up to do what you need to do. You can calculate the average daily balance now that you have that table completed. And how do you do it? The easiest way, and the way I recommend, is to use the stats mode and calculate this as a mean. And we just did that. So what you do is you take your calculator, you press the on key to make sure you've cleared out any old information that might have been stored in the calculator. Then you take mode period, that puts you in stats mode, and then you type in the first daily balance, the number of times indicated by the number of days. So the original daily balance was $246, and it was valid for 7 days. So you type in 246, and then you hit M plus 7 times. And then you move to the next daily balance, which was $363. So you type in $363. Notice it was valid for 16 days, so you press M plus 16 times. Take your time, make sure you get 16 of them. And then finally, there was a $163 daily balance, valid for 8 days, so you press M plus 8 times. And once you get the data in, all you have to do is press Shift 7, and that tells you the average. And it comes out to be $284.97. You have to be careful, and one mistake throws you off on the entire answer. and it's especially problematic to miss the number of days because that's going to throw everything off quicker than anything else. Just be careful in your calculations, go slowly, and use the stats mode with the shift 7 at the end. Number 18. A charge account had a balance of $994 on May the 5th. A purchase of $288 was made on May the 17th, and a payment of $175 was made on May the 20th. The interest on the average daily balance is 1.5% per month. Find the finance charge on the June 5th bill and round your answer to the nearest cent. Now this problem is asking for the finance charge. And remember, the finance charge is ridiculously easy to calculate if you know the average daily balance. It's just the average daily balance times the monthly interest rate. But we don't know the average daily balance. So we have to find the average daily balance before we can find the finance charge. So step 1 is to find that average daily balance. To calculate the average daily balance, you build your 4-column table. Column 1 has the dates. Column 2 has the changes in balance. Column 3 has the daily balance. And column 4 has the number of days that balance is in effect. So you start reading the problem and you look at the earliest date mentioned, which is May the 5th. On May the 5th, you had a balance of $994. Then you read through and look for the next date. The next date you see is May the 17th. On May the 17th, you made a purchase of $288, so that increased your daily balance. So if you take the change in balance of $288 and add it to the $994 you already owed, your daily balance now is $1,282. At this point, you can go back up and look at line 1 and see that if the new balance started on May the 17th, the old balance was in effect until the day before, which was May the 16th. Once you get May the 5th to May the 16th, you can count the number of days. Remember, you can use the formula for consecutive integers. It's largest minus smallest plus 1. That'd be 16 minus 5 is 11 plus 1, you get 12. Or if you're not sure, just write the days down and count them manually. You cannot afford to miss the number of days. In any case, it comes out to be 12. Now you keep reading through the problem and find the next date mentioned. The next date mentioned was May the 20th, and on May the 20th, a payment of $175 was made. You can also look and see that if the payment was made on May the 20th, that means the other date went through the 19th. That payment on the 20th was $175. That payment reduces your daily balance, so that's like a negative $175. And if you take $175 away from that $1,282, which was the previous daily balance, you get $1,107. So the daily balance now is $1,107. You can go up and find out how many days that $1,282 balance was valid by subtracting 19 from 17, add 1, or just writing down 17, 18, 19. Either way, you'll find out there are 3 days for that. And you can also see, if you look at the last date in the problem, the last date was June the 5th. As I said, June the 5th is the billing date, so it ended the day before, which is June the 4th. So you've got to count the days between May the 20th and June the 4th. You have to realize that you need to know how many days are in months. May has 31 days. So when you count, you've got to count every day up through May 31st. If you write them all out, it might take a little bit, but if it keeps you from missing a problem, it's worth it. Anyway, it turns out to be 16 days. You've got the 1st, 2nd, 3rd, 4th of June, and then you have 12 days back in May. However you get it, you've got to be careful and get it right. It turns out to be 16 days. And now you're done with the table. You're ready to put it in the calculator. All you do is use the calculator stats mode and find the mean. You enter every daily balance for the number of days indicated. So you start off with the $994. It's valid for 12 days. So you enter $994 by pressing M plus 12 times. Then you drop to the next daily balance of $1,282. It was valid for 3 days. So you press M plus 3 times. Then you go to the 1107. It was valid for 16 days. So you have to press M plus 16 times. When you get all those numbers in, you press Shift 7, and that gives you $1,080.19. That's the average daily balance. But remember, the problem wanted the finance charge, but we had to calculate the average daily balance before we could get the finance charge. So we're not done, but we're done with the hard part. The finance charge is easy once you know the average daily balance. The finance charge is just the average daily balance times the interest rate per month. So the average daily balance was $1,080.19. The interest rate was 1.5% per month, which is 0.015. And if you multiply those numbers together and round things off to the nearest cent, you get $16.20. So that account would owe a finance charge of $16.20. Number 19, Arrowwood's Camera Store advertises a Canon PowerShot 3.34 megapixel camera for $475, including taxes. If you finance a purchase of this camera for 1 year at an annual percentage rate of 6.2%, find the monthly payment and round your answer to the nearest cent. This is the payment for an APR, annual percentage rate loan. You just have to learn how to use it. We're looking for the monthly payment, that's the PMT. A is the amount of the loan, R is the interest rate or the APR, N is the number of compounding periods in a year, and T is the time in years. So you just pull that information from the problem and plug it in. The camera is $475, that's the A, that's the amount of the loan. The interest rate as a decimal is 0.062. There are monthly payments, so N is 12 because it's compounded 12 times a year, and you're doing it for 1 year, so T is 1. Plug those numbers into the formula. Now, I've said this before, but be careful with these problems that have a fraction within a fraction. Before you start doing it on your calculator, be sure to put parentheses around the entire numerator and the entire denominator, and also multiply the numbers in the exponent before you get started plugging directly into the calculator. So first of all, numerator, denominator percentages, and multiplying the exponent and get a single number. If you do those two things, it's ready to go in the calculator. So here we go. You type in the 475. It's an implied multiplication, even though there's no multiplication sign, so you have to hit times. And then we've gone through this several times. You've got to hit a left paren to take care of that first brace. That throws you into the numerator, and there's another left paren. Then you type in 0.062 divided by 12. Then there's a right paren, type that. Now you're at the main fraction bar of the big fraction, so that's a division symbol. That throws you in the denominator, and you have a left paren. Then you have 1 minus, and then you have another left paren, and then you have 1 plus. That takes you to that last little fraction in the denominator. That's 0.062 divided by 12. Then you've got a right paren. That takes you to where you need to get up in the exponent, so you have to hit the power button next to the y. Then you have to type in a negative number, and the only way to do that is to type in the positive value, which is 12, and press the plus minus key. Now you want to close that right paren, the very last thing in the denominator of that big fraction. That takes you to the last bracket, which is another right paren, and finally press equal to, and if you do all that, you get a payment rounded to the nearest cent of $40.93. Now, if you're having trouble with the step-by-step button presses to get this, go back to the lecture where I did that in more detail and took it more step-by-step and practice that, and then come back here. Number 20. After becoming a commercial pilot, Lorna Cow decides to purchase a Cessna 182 for $64,855. Assuming the sales tax is 5.1% of the purchase price, find each of the following. Part A is, what is the total cost including sales tax? The sales tax is simply the cost of the Cessna times the sales tax rate, which is 5.1%, and 5.1% as a decimal is 0.051. So you simply take 0.051 and multiply it by $64,855, and round it to the nearest cents would be $3,307.61. The question was, what's the total cost, including the sales tax? So now that we've calculated the sales tax, we have to add it back on to the price of the Cessna. So the price of the Cessna after sales taxes will be $68,162.61. The B part says, if Lorna makes a down payment of 22% of the total cost being what we just calculated in Part A, find the down payment. So all we have to do is take 22%, which is 0.22, 22% of $68,162.61. And if you multiply, you'll get $14,995.77. So Lorna made that down payment on the total cost. Part C says, assuming Lorna finances the remaining cost at an annual interest rate of 7.05% for 10 years, find the monthly payment. Okay, the amount borrowed was the Part A answer, $68,162.61. But she's not going to finance the entire amount. She's going to make a down payment of $14,995.77. That's the B part answer. So Lorna is only going to finance $53,166.84. So that's the number that we got to use in the formula. So you use the formula for the monthly payment and use A equal to $53,166.84. The interest rate is 7.05%. Of course, you have to change it to a decimal. You're doing it for 10 years, so T is 10, and it's monthly, so N is equal to 12. Plugging all those numbers in, you get that, and as usual, I would recommend multiplying the numbers in the exponent together and putting parentheses around the entire numerator and entire denominator. 12 times 10 is 120, so it's a negative, so it would be negative 120. And if you put parentheses around the entire numerator and entire denominator, you get that. Now it's ready to be put into the calculator. I'm not going through it step by step, but you can go back to earlier problems where I did do a step-by-step solution. But you need to press all those keystrokes, being very careful, making sure you don't miss any parens and that you enter negative numbers properly. Just being very careful, and when you press that last equal to, you'll get a monthly payment of $618.68. Number 21, Luis Mala purchases a Porsche Boxster for $41,100 and finances the entire amount at an annual interest rate of 4.7% for 6 years. Find the monthly payment. Assume the sales tax is 6% of the purchase price and the license fee is 1% of the purchase price, and round your answer to the nearest cent. We've got to calculate that sales tax. It's 6%, which is 0.06, so we multiply 6% of $41,100 and you get $2,466. That's the sales tax. Then we've got to calculate the license fee. It's 1% of the purchase price, so you take 0.01, 1% is 0.01, and multiply it by $41,100 and you get a license fee of $411. So it's the price of the car plus the sales tax plus the license fee. So those three numbers added together give you $43,977. So Luis is going to get a loan on that amount. So you plug it into your formula to figure out the monthly payment. The $43,977 is A. The interest rate as a decimal is 0.047. It's monthly, so N is 12, and we're doing it for 6 years. Plug those numbers in, multiply the numbers in the exponent, and put parentheses around the entire numerator and the entire denominator, and you will get the formula so that it's ready to type into the calculator. Again, I'm not going through this step by step, but those are the keystrokes, and as soon as you press equal to, if you're careful and didn't make any mistakes, you'll find out that the monthly payment is $102.14. Number 22. Samuel Nidge received a 5-year subsidized loan of $19,000 at an annual interest rate of 6%. What are Samuel's monthly loan payments for this loan when he graduates from college in 2 years? And round your answer to the nearest cent. Again, we're looking for a monthly payment, so we use the monthly payment formula. $19,000 is the amount borrowed. The interest rate is 6%, which is 0.06. It's monthly, so it's N equal 12, and we're doing it for 5 years. Multiply the exponents in the denominator and put parentheses around the entire numerator and denominator. When you do that, the formula is ready to type in the calculator. And when you do that, again, I'm not going through it step by step, but you can go back to earlier problems where I did. you'll get this, a monthly payment of $367.32. Number 23, a stock pays an annual dividend of 84 cents per share. Calculate the dividends paid to a shareholder who has 200 shares of the company's stock. Number 24, find the dividend yield for a stock that pays an annual dividend of $1.75 per share and has a current price of $70. Round to the nearest hundredth of a percent. Think about it this way. Determining a dividend yield is similar to calculating the simple interest rate earned on an investment. You can think of the dividend as the interest earned and the stock price as the principal and the yield as the interest rate. So it's really a very similar calculation. So the amount of dividend can be thought of as the simple interest formula, where capital I is the amount of the dividend and the principal is the stock price and the yield is the interest rate. So basically you're using I equals PRT. The dividend is $1.75 per share, so that's like the capital I. The principal is like the stock price, so that's 70, and the time is for a year, so T is 1. If you solve that equation by dividing both sides by 70, you'll find out that the interest rate is 0.025, written as a percent is 2.5%. It's said to round it to the nearest hundredth of a percent, but 2.5 comes out even, so you could write it as 2.50%, but since it comes out even, that last zero is not necessary, but you could put it there. Number 25. Use the given partial stock table. Round dollar amounts to the nearest cent when necessary. Suppose you own 500 shares of stock in General Electric. You purchased the shares at a price of $22.08 per share, and you sold them at the closing price of the stock given in the table. Most of those column headings are self-explanatory. For instance, DIV is just the annual dividend. Those first few columns relate to the particular day in 2015. Most of the columns after that are not specific to a particular day. But what you need out of this is what is the information required to answer the question. And the question they're asking is, if you ignore the dividends, what is the profit or loss on the sale? Well, if they're asking about profit and loss on the sale, and they're asking about General Electric in particular, you're only interested in the next to the last row of the table, which is the GE row. So in order to answer this question, you have to know how much the stock was worth when it was bought, and you have to know how much the stock was worth when it's sold. And the difference between those two numbers is your profit or your loss. If you sold it for more, it'll be a profit. If you sold it for less than you bought it for, it's going to be a loss. So let's go back and look at those two numbers. When we bought the stock, or when this person bought the stock, there were 500 shares bought at $22.08 per share. And if you multiply that together, you'll find out that that stock was valued when it was bought at $11,040. But what about when it was sold? Well, when it was sold, you need to look at the table to see what the price per share was when it was sold. If you look at the chart, you already know there are 500 shares. What you need to know is how much the shares sold for, and that chart tells you when the market closed on that day in 2015, when the stock was sold, it sold for $29.36. The closing column gives you the information on the price per share when it was sold. So we want to multiply 500 by 29.36, and that comes out to be 14,680. That's bigger than the 11,040 that the stock was worth when it was bought. So we're going to have a profit, and if you subtract, you'll see that the profit is $3,640. Very straightforward. That whole table is there, but you've got to focus in on what's important. You're only looking on the General Electric line, and then you have to look at the column that applies to what the question is. And here we were looking at the price per share information, and that's in the closing column. That's the value of the stock when it closed that day. Another question. What's the broker's commission if she charges 2.5% of the total sales price? Well, the sales price was that $14,680. if she charges 2.5% of that, you just take 2.5%, change it to a decimal, that's 0.025, and multiply it by $14,680, and you'll find out that the broker's commission was $367. So the broker charged you $367 to make that sale. Number 26. A bond has a $10,000 face value, a 5-year maturity, and a 3% coupon. Find the total of the interest payments paid to the bondholder. Now you have to know what all these terms mean. The price paid for the bond is the face value. The issuer promises to repay the bondholder on a particular day. That day is called the maturity date at a given rate of simple interest, and that interest rate is called the coupon. So as odd as the word coupon might sound in this context, it's just the interest rate. When we say a 3% coupon, that just means 3% interest. So we use the simple interest formula, I equals PRT. The principal is the face value, it's $10,000. The interest rate is 3%, which is 0.03. It's a 5-year maturity, so the time is 5 years. And if you plug in and calculate 10,000 times 0.03 times 5, you'll find out that the amount of interest is $1,500. Number 27. If you buy a $256,000 home with a down payment of 27%, find the amount of the down payment and the mortgage amount. The down payment was given to be 27% of the purchase price, so you take 27%, which is 0.27, times the purchase price, which is $256,000, and you'll end up with a down payment of $69,120. So the mortgage amount is just the home price minus the down payment. So that's $256,000 minus $69,120. So the mortgage amount is $168,880. That's the amount of the mortgage. Number 28. Clarissa Madison purchases a home and secures a loan of $230,000. The bank charges a fee of 2.27 points. Find the charge for points. Remember, point just means percent. Coupon means percent. Point means percent. The points charged then is 2.27%. As a decimal is 0.0227. Multiply that by the loan amount, which is $230,000, and you end up with $5,221 in points. Number 29. Find the mortgage payment for a 15-year loan of $223,300 at an annual interest rate of 8.15%, and round your answer to 2 decimal places. Remember, your formula for monthly payments on a mortgage is something you'll be given, but you do have to know what all the letters stand for. PMT is the monthly payment, A is the amount of the mortgage, R is the annual interest rate, N is the number of payments per year, and we'll always be doing monthly for these mortgage payments, so N will always be 12. So you go to the problem and you pick the numbers out. A is $223,300. The interest rate is a decimal, is 0.0815. It's monthly, so N is 12, and we're doing it for 15 years, so T is 15. Remember, you need to do 2 things when you have a problem with a fraction within a fraction and an exponent that needs multiplying out. You multiply out the 12 times the 15, and remember it's negative, and you want to put parentheses around the entire numerator and the entire denominator. Once you do those 2 things, the calculator is ready to be used. You can take it and plug this directly in the calculator. Again, I've done this in earlier problems where I've gone more detail by the steps, but I'm just going to put it here and assume that by now you've gotten these keystrokes down. But you have to be careful, and remember, once you type in the 223,300, that's an implied multiplication, so you do have to press times. In any case, if you're having trouble with these steps, go back to a problem earlier sections where I actually took more time going step by step. When you press equal to on this calculation, though, you should get a monthly payment of $2,153.35. Number 30. Richard Maeshero purchased a condominium and obtained a 30-year loan of $198,000 at an annual interest rate of 8.2%. Round your answers to the nearest cent. First question is, what is the mortgage payment? Again, you've got to use the formula for the mortgage payment. All the letters are the same. A is the amount of the mortgage, which is $198,000. The interest rate is 8.2% as a decimal, which is 0.082. It's monthly, so N is 12, and we're doing a 30-year loan, so it's 30 for T. You want to multiply 30 times 12 for that bottom exponent and get an answer there. And of course, remember it's negative, so it comes out negative 360. And you want to put parentheses around the entire numerator and denominator. Once you do that, the formula's calculator ready. And you carefully type that expression into the calculator, and you get a monthly payment of $1,480.55. Then you go to part B. What is the total of the payments over the life of the loan? Well, just think about it. You're paying $1,480.55 a month for 12 months a year for 30 years. So it's just the product of those three numbers. And if you multiply $1,480.55 times 12 times 30, you end up with over $500,000, $532,998. So over the life of that 30-year loan, even though you just borrowed $198,000, you end up paying back over $500,000, $532,998. And part C, find the amount of interest paid over the 30 years. That's just the difference between the B answer and what you borrowed. So you ended up paying $532,998. You borrowed $198,000. So the difference between those two numbers is the interest you paid the bank, which comes out to be $334,998. And you know, that's quite a bit more than what you borrowed. That's just the interest. You actually paid back over $500,000. Number 31. You have saved $16,000 for a down payment on a house. Your bank requires a minimum down payment of 11%. What is the maximum price you can offer for a home in order to have enough money for the down payment, and round your answer to 2 decimal places? This requires a little bit of algebra, at least the first time you work it. After you've gone through it, you can sort of see what you have to do to get the answer. But if you let X be the price of the house, the minimum down payment is 11% of that, which is 0.11. So if you take 0.11 times the price of the house, that's the minimum down payment. And according to the problem, it had to be that $16,000 because that's what you saved up. So if you set the minimum down payment equal to what you've saved, if you take both sides of that equation and divide it by 0.11, you'll find out that the price of a house that you could afford with a down payment of $16,000 is an $145,454.55 house. A house any more expensive than that would require a down payment of more than you have, and so you wouldn't be able to do it. And notice in the end, even though we did algebra, what you really wind up with is the down payment that you saved divided by the interest rate as a decimal. That's really all it's going to come down to.